Hi guys. So today we are going to build on what we did in that Desmos activity, and we are going to look at the math that goes behind some of these transformations. So to start, we're going to look at a table of points, and we're going to look at how to transform this graph. So what we saw in that Desmos activity, this f of x plus 4 transformation is going to take my graph and shift it up 4. Because remember, if it's outside and away from the x, it's going vertical, and then vertical stuff is going to stay consistent. So these points over here on the left, this little box, those are the original points on my graph. So to translate these points up 4, I'm going to do f of x plus 4. That means I take the y coordinate and I add 4. So negative 2, when I add 4, becomes 2. 2 plus 4 is 6. Negative 2 plus 4 is 2. 2 plus 4 is 6. So my new coordinates that I'm plotting now are negative 1, 2, 1, 6, 3, 2, and 5, 6. So from there, connect the dots, and there's my graph. Now, when we get to horizontal transformations, it's a little bit different. So based on what we saw in that Desmos activity, f of x minus 2 is going to go right 2. So what that means here, the y coordinate is not changing. So in order to have a y coordinate of negative 2, I need what's in the parentheses here to be negative 1. So I need to think, what x value can I plug in to that x to get an answer of negative 1 in the parentheses? So in order for that circled part to be negative 1, the number I would plug in is 1. On the next one, similar concept. I want that circled part to give an answer of 1. Well, if I plug in 3 into that x, that would give me a value of 1. Same thing on the next one. If I plug in 5, 5 minus 2 then gives me 3. And then on my next one, if I were to plug in 7, plugging in 7 would give me that answer of 5. So now when I plot those new points, you'll see that's how this graph ends up being transformed to the right. So again, the big thing to remember, if it is away from the x outside the parentheses, it's up and down. If it's inside the parentheses near the x, it's going to be side to side. All right, now looking at my next one, this one has both a horizontal and a vertical change. So let's deal with the horizontal one first. The first value that's here is what I would plug in for x to get negative 1. So if I plug in negative 2, 1/2 times negative 2 will give me negative 1. Now go to the next one. If I plug in the value of 2, 1/2 times 2 gives me 1. If I plug in 6, that would give me 3. And if I plug in 10, that would give me 5. All right, then on my y's, all I have to do is look at the y change, which is just that negative. So I just take the y coordinate and just make it negative from what it was. The vertical transformations are much simpler. You just apply exactly what it is directly to the points in the order you would assume that you do it. So negative 2, 2, 2, negative 2, 6, 2, and 10, negative 2. So you can see that graph, that is a horizontal stretch. So the 1/2 on the inside there is stretching that graph horizontally. That graph has also been reflected over the x-axis. All right, transformations. So this is a big list of everything that we saw on the Desmos activity. So we're going to describe it and then look algebraically what's happening to those points. So this first one is a shift to the right. The next one is a shift to the left. Then below that, if b is greater than 1, that is a horizontal compression. If b is in between 0 and 1, that is a horizontal stretch. And then on that last one, that is a reflection over the y-axis. So that's describing what's happened. All of those are horizontal changes. Since those are all horizontal changes, those are all going to affect our x-coordinates. So what I would do algebraically to those points is I would take, on that first one, I would take the x, and I would add the value of h. This next one, I would take x, I would subtract the value of h. I would take x and I would divide by b. Take x and divide by b. Then that last one, I would just take that answer and make it negative. That second box, those are all vertical transformations. So again, notice all the horizontal stuff was near the x inside the parentheses. All the vertical stuff is away from the x outside the parentheses. So the first one, that is a shift up. This one is a shift down. That a on the outside, if that number is greater than 1, that is a vertical stretch. And then if a is in between 0 and 1, that is a vertical compression. That negative out in front is a reflection over the x-axis, because again, that would change it vertically. So all of these are affecting vertical, so all of these are going to affect the y-coordinate. So again, what would happen here is I would take the y-coordinate and add k. Y-coordinate minus k. A times the y-coordinate, and then negative y-coordinate. So this first example, we're going to apply that operation to it. So what we have is we have the point 2, 3, and 2, 3 is going to have all these transformations applied. So if I have f of negative x, so f of negative x means I'm going to reflect over the y-axis. That's going to affect my x-coordinate. So all I would do is take my x-coordinate and make it negative. On b, that 2 out in front is a vertical stretch. So what that would do is I would multiply my y-coordinate by 2. C, that transformation is left 7. So it's only going to affect the x-coordinate. I'm going to do set 2 minus 7. So again, if I'm going left, it's 2 minus 7. Does not affect the y-coordinate. D, again, be careful. This is the one that's probably the most missed. That is a horizontal stretch. That is a horizontal stretch. So that means I'm going to take my x-coordinate and I'm going to multiply it by 3. So 6, 3 is my new point. D has 2 transformations. Now, when it comes to multiple transformations, you need to be careful, but they're a little bit easier if there's only one horizontal and one vertical. Horizontal and vertical transformations won't affect each other. The horizontal transformation, which is right 1, is only affecting the x-coordinate. So my new x-coordinate, I'm going to take 2, and I'm going to add 1, which puts me at 3. Then to get the y-coordinate, I take 3, and I add 3, which puts me at 6. All right, E, again, there's one horizontal and one vertical transformation. So let's look at horizontal first. The horizontal transformation is that this is being compressed horizontally. So I'm going to take my x-coordinate 2 and divide it by 2. So my new x-coordinate is 1. Then the negative, I'm going to take the y-coordinate and make it negative, which is negative 3. On F, F has one horizontal transformation but 2 vertical transformations. So if I look at x plus 2, that graph is going to be shifted left 2. That means I'm going to take the x-coordinate and I'm going to subtract 2. So 0 is my new x-coordinate. Then if I look at the y-coordinates, there are 2 transformations here. I have a vertical stretch and I'm shifting down 4. When there are multiple transformations, for vertical, you can always follow PEMDAS order. So for our vertical transformations, I'm going to follow PEMDAS. So what I'm going to do is I'm going to take 3 times 3 minus 4. So 9 minus 4 is 5. So for vertical transformations, follow normal PEMDAS order. For G, let's go ahead and do the y-coordinate because we just talked about that. I'm going to follow PEMDAS order. So I'm going to multiply by negative 1, and then I'm going to add 2. So I take my y-coordinate, it becomes negative 3. Negative 3 plus 2 becomes negative 1. And that's my y-coordinate. The x-coordinate on this one's a little bit trickier. When there are 2 horizontal transformations, there are a few different ways that you can find this. What I typically do, and the way I'll show this when we get to some actual functions, I like to factor out whatever that b value is. So what I mean by that is I'm going to take whatever is in front of the x and factor it out. So right now what's in front of my x is negative 2. If I factor out negative 2, that's going to leave me with x plus 2. And then I still have my original. The reason I like to factor it out is now we can follow PEMDAS order. So if I didn't factor it, I wouldn't be able to follow PEMDAS. Now you can still get the correct answer, but if you want to be consistent about your PEMDAS order, then you need to factor that value out. So what I would do now is I'm going to take my x coordinate 2, I'm going to divide by negative 2, and then I'm going to subtract 2. So that gives me negative 1 minus 2 is negative 3. Now that's not the only way to work this question out. Let's say you didn't factor it. You could still get the correct answer. What we would do though is we do not follow PEMDAS. So what I would do instead is I would take 2, I would add 4, and then I would divide by negative 2. And that still gives me the same answer. Now if that still doesn't work, the other way we can work this out is the way we did the table. What we did on the table was we took what was in the parentheses and we'd try to figure out what would make the what x value would make that equal my original number. So you can just set that up as an equation, add 4, divide by negative 2. So I end up with x equals negative 3. So 3 different ways to work that out. Just the biggest thing here is just be careful when you have more than one horizontal transformation. Vertical transformations are much simpler. Stay consistent with PEMDAS. All right, so now what we're going to do is we're going to actually apply this idea to some graphs. So what we're going to do, I have f of negative x. So I first need to recognize that is a reflection over the y-axis. So what that means is all the x coordinates are going to be made negative. So if I start with the point negative 3, 0, that point is going to get reflected to positive 3, 0. If I had the point negative 2, 1, that gets reflected to positive 2, 1. If I take the point negative 1, 2, that gets reflected to positive 1, 2. 0, 0 stays 0, 0. 1, negative 1 gets reflected to negative 1, 1. And then finally, my last point, 2, 2 gets reflected to negative 2, 2. So now what I'm going to do is I'm going to erase my original points so we don't get confused. And then all I got to do is connect my dots. So here is my graph. All right, so looking at B. So this one has a horizontal and vertical transformation. We're going to reflect over the y, and we're going to go up 2. So very similar. I'm going to start with negative 3, 0. I'm going to take that point, I'm going to reflect it over the axis. After I've reflected it, then I'm going up 2. So that's my new point. All right, now we're going to do negative 2, 1. I reflect that point to positive 2, 1. Then I shift it up 2. All right, negative 1, negative 2. I reflect it, and I shift it up 2. 0, 0, I reflect it, and I shift it up 2. 1, negative 1, I reflect it, and I shift it up 2. And then 2, 2 gets reflected and shifted up 2. So there's my new graph. Whoops, that's my eraser. All right, so now let's try a few more. Oops, skipped too far. All right, on C, that has both a horizontal and vertical change. This graph is going to go to the right 2 and up 1. So I take each of those points. So starting here, right 2, up 1. There's my new point. Take my point here, right 2, up 1. Right 2. So from here, I'm going to go right 2, up 1. 0, 0, right 2, up 1. From this point, I'm going to go right 2, up 1. And then from my last point, right 2, up 1. And there's my function. The shape and size of that graph has not changed since it has not been reflected or compressed. It's only been shifted. All right, D gets a little bit tougher because now we have multiple vertical transformations. This graph has been vertically stretched, it's been shifted down 1, and it's gone left 3. So we're going to follow PEMDAS order. So I'm going to start with the vertical because it's a little bit harder. So this point right here at negative 3, 0. The y-coordinate is 0. So I multiply that by 2, it's still 0. Then I shift down 1 and left 1, 2, 3. And there's my new point. Negative 2, 1. I take the y-coordinate and multiply it by 2. So 1 times 2 is 2. Then I shift it down 1, and it's back at the same y value. But then I also go left 1, 2, 3. All right, using this point down here, or multiply it by 2, shift it down 1. So that's the new y-coordinate. Then I take that point and I move it over 1, 2, 3. All right, following that same pattern, here's my point. Multiply it by 2, it's still 0. Shift it down 1, right, left, 1, 2, 3. All right, let's point over here. Multiply it by 2, shift it down 1, and then left, 1, 2, 3. All right, and then this point over here, multiply it by 2, shift it down 1, and then left 1, 2, 3, and there's my final point. Then all I gotta do is connect my dots. All right, the last one's on here are a little bit trickier because these have multiple horizontal transformations to consider. So at this point, again, what I like to do is I like to factor out because it just gets us in a good habit. If you don't factor it out, you can still get your correct answer, but your order will change. So what I'm going to do is I'm going to rewrite this. I'm going to factor out the 1/2 and make this x minus 2. So from here, that means this graph has a horizontal stretch by 2, and this graph is going right 2. All right, horizontal stretch by 2, and it's going right 2. So what I'm going to do is I'm going to take that point. I'm going to stretch it horizontally, which means I'm going to multiply it by 2. So that puts it at 6. Then I go right 2, which moves it back to that location right there. All right, looking at negative 2, 1. I take the x, I multiply the x by 2. That puts it at 4. Then I go left 2, which puts it back where it was. I look down here at the bottom point. I multiply it by 2, which puts me here. Then I go left 2, which puts me at 0. 0, 0 times 2 is still 0, and then right 2. 1, negative 1 times 2, right 2. And there's my point. And then this point up here at the top. Times 2 puts me at 4, right 2 puts me at 6. So then I'm going to connect my dots. And you can see that graph, same graph, just wider. And let me go over that in black so it's a little bit clearer to see. And then the Schoology notes will be a little bit clearer to see where that graph is. All right, the last one has multiple transformations on it. There's 2 horizontal changes, there's 2 vertical changes, so this one's pretty tricky. So what I'm going to do on this one instead, to look at it a different way, I'm going to list the points and do this algebraically. So I'm going to list my points on my graph, which are negative 3, 0, negative 2, 1, 1, negative 2, negative 1, negative 2, sorry, 0, 0, 1, negative 1, and 2, 2. So the transformations that are being applied here. To the vertical changes, I have a reflection and shifting down 1. So that means my y-coordinate, I'm going to make it negative, and then I'm going to subtract 1. So let's go ahead and do our y-coordinates. So negative 0 minus 1. negative 1 minus 1. Negative negative 2 becomes positive 2, 2 minus 1. Negative 0 minus 1. Negative negative 1 is positive 1. 1 minus 1 is 0. Negative 2 minus 1 is negative 3. So that's all my y coordinates. Now let's look at the x coordinates. Again, I'm going to factor out that 2. That means this is a horizontal compression and a shift left after that horizontal compression. That means I'm going to take my x coordinate, I'm going to divide it by 2, then I'm going to subtract 1. So negative 3 divided by 2 is negative 1.5, minus 1 is negative 2.5. Negative 2 divided by 2 is negative 1. Negative 1 minus 1 is negative 2. Negative 1 divided by 2 is negative 1/2. Minus 1 is negative 1.5. 0 divided by 2 is 0. Minus 1 is negative 1. 1/2 minus 1, negative 1/2. And then 2 divided by 2 is 1. 1 minus 1 is 0. Then all I got to do is plot those points. So negative 2.5, negative 1. Negative 2, negative 2. Negative 1.5, 1. Negative 1, negative 1. Negative 1/2, 0. And then 0, negative 3. So a really squished together graph with that horizontal compression. So here is my final function. All right, so again, the biggest takeaways here. Anything that is near the x inside the parentheses is a horizontal transformation. When we apply those algebraically, it's backwards. So plus goes left, minus goes right. The number in front, if it's less than 1, that's a horizontal stretch. The vertical stuff is outside and away from the x's and away from the parentheses. And that one we treat just like normal operations in normal PEMDAS.